Good morning, ladies of calculus. Welcome room 15, where?
Learning never ends.
Learning never ends, even when half the class is gone, right? Now yesterday we had a kind of a short class. We talked about the course of calculus. I don't know how helpful it was. If anything, it was different than what we've done a little bit. So we talked about it, yes.
I knew that you were asking questions yesterday. Was it because I was asleep half of it?
Well, partially, but I was asking questions I would have asked normally.
Okay,
So
well, I did fall asleep. I'm just
It wasn't just for you. Yeah, it's hard. It's hard. It's a hard thing. And I know Kaylee has time, and I has a hard time at it, and maybe others do too, maybe not as much. But it's really a hard time to have a class right after lunch, isn't it?
Right after lunch, and then it's always dark in here, and it's warm, so.
Yeah, dark. So it's like a combination of things.
Yeah.
And I think,
It's just,
yeah, it is. And what happens is and I want to have it dark in here so we have more visibility up here. I mean, it's kind of dark. So that's the reason for that. As far as being warm in here, it kind of in the afternoon trends a little warm. Right now it's at 71, but it feels a little warm, not quite. It gets worse later in the afternoon than this anyway. Like I'll turn on the fan a little bit sometimes, but usually fifth period is not so bad. But what we're doing on these exercises, we were working on this number 2, and we're going to do these exercises, and we have a variety of exercises. So I did number 1, we went over that a couple days ago, and we started on number 2, and we found, first of all, the critical numbers, and it ended up that we had a non-factorable expression here, and so we ended up with critical numbers of 1 minus 2 square root of 2 and 1 plus 2 square root of 2. And so we have, so that's what this thing looks like here. And then if you take the second derivative of this from 3x squared minus 12x, you get 6x minus 12. And then the critical number for this is going to be minus 2, or 2, x equals 2. And so the second derivative figures out what concavity is. And so we see that we have our concavity changes from negative to positive at x equals 2. So therefore, there's a point of inflection at x equals 2. And why? Because y double prime changes from what? From negative to positive. And what else are we being asked here on this? I'm just trying to look at what it says. So determine where it has relative extrema, justify each, and find the value of each extrema. Concave up and concave down, determine where the function has a point or points of inflection, and we justified that E. And so, oops. So we have concave up on this interval here from 2, infinity, because y double prime is greater than 0. We have concave down on the rest of the domain, negative infinity to 2, and y because y double prime is less than 0. And then we have, this is where we have our critical numbers here. We have a relative maximum at x equals 1 minus 2 square root of 2, and a relative minimum at x equals 1 plus 2 square root of 2. So basically that's it, isn't it? So to me, The only thing that or I'll just ask you, what do you find that was hard about this one?
The getting it from 3x to the, what is that? Because it's non-factorable?
Yeah, that's right. That's what I agree with you on that one, Kate, because what it is I went to factor this, found out we couldn't factor it, and so we're kind of stuck having to use the quadratic formula. But once we use the quadratic formula, find what it is, but the concept of it is not that hard, is it? It's just, that's what it is there. I found in my experience, both in writing tests and in seeing problems in tests, usually you don't run across this very often, that you have a non-factorable situation, but it's possible. But if you see that again, are you going to be ready for it? Yeah, maybe not, maybe not.
Probably not.
Probably not. But what I want you to do, I guess what I really want you to do is I want you to open your mind to the possibility that that could happen. Could you do that?
Yeah.
Yeah, so just be ready, try to be ready for anything.
Oh, but you could also open your mind to not putting it on a test.
Yeah, and I can't think of any test that I've done that I've had this that I've written. I don't know, but sometimes I use like AP problems that aren't of my own invention too. So I don't remember this being on my test, something where that is needed. And part of the situation is that I want the test, if the test is comprehensive, I don't want you to be spending all day stuck on something. So that's part of the reason for that. So what I want you to do is go ahead and work out number 3, the same thing, find the critical numbers, and so forth. My recommendation in advance is that you can, for this thing, like use a product rule on this when you differentiate and find that. What is a product rule? It's note card number, whatever it is, product rule. The derivative is uv squared plus vu prime plus uv prime. That's what it is. Today when I was driving into work, I ended up being right behind my car ended up being right behind Miss Kelso's car. You know what Miss Kelso told me when we drove in today? She told me I have a headlamp that's out. Sure enough, I do. And it was a headlamp that I replaced myself less than 3 months ago. Now, is that annoying?
Yeah.
That's annoying.
Is the prime of x 1 or 0?
Yes, f prime of x, if you have if f of x is x, then f prime of x would be 1. Yes. That's some good calculus right there. What I would do with this one here, I go like this. So I'd have x, x prime, and then I'd have I have 3 so I'd have those things right here. So I'd have f prime of x is equal to 3x times x minus 4 squared plus x minus 4 to the third power. Okay, how are you going to find your critical numbers for this? Set this equal to 0. So we have 0 equals 2, and what we have is we have greatest common factor here is going to be this x minus 4 to the squared, right? So we square that, and then what times x minus 4 squared equals 3x times that? Well, it's going to be 3x, right? And then we're going to have plus remaining of that. So we're going to have plus x minus 4. And so if we can set each one of these equal to 0, right? So we have x minus 4 is equal to 0. So what is one of our critical numbers? It equals 4. And then this other one here, we have 3x plus x minus 4. So that's going to be 4x minus 4 is equal to 0. So what is x equal to here? X is equal to 1, right? So x is equal to 1, x is equal to 4. So those would be your critical numbers. Is that what you got for that one? Mm-hmm. Yeah. So now we're trying to find the relative minimums and maximums. So if we go to 1 and 4 right here, here's 1, here's 4. And so we're going to put the f, let's see, f prime and f down here. And if we have a number less than 1, and this thing here is always going to be positive, right? Where it's not 0, it's going to be 0 here, but everywhere else positive. So we're going to have a positive, and if we have a number less than 1, is that going to be negative or positive? That's going to be negative, because we have a negative times a positive. And greater than 1 is going to be what? Positive, and that's always positive, so we have that. And then we have, for this next one, this one is still positive, and this one's always, because we didn't, our multiplicity is 2, so this is positive also, isn't it? So we have critical numbers, x equals 1, x equals 4, and do we have a relative maximum? No, we don't. But do we have a relative minimum? Yes, we do. We have a relative minimum at x equals 1 because why? F prime does what? what is happening between this f prime here and this f prime over here? What is f prime doing from here over to here? Changes, right? So changes from negative to positive. And then they're asking, what is that value? Well, if we plug in for 1, so f of 1 is equal to 1 times 1 minus 4 cubed. What's 1 minus 4? Negative 3, right? So we have negative 3 cubed, which is going to be negative 27. So negative 27 is our relative minimum where x equals 1. Okay, the next thing they're asking for is what? The f double prime, right? So here we have f double prime of, or well, I'll put f prime of x. Let's do it that way. We know f prime of x is equal to this x minus 4 squared, and then we have times this 4x minus 4, right? I mean, that's our f prime of x. And so what's f double prime of x going to be? That's where we need to go next.
2, I don't know.
You just go like same thing. Boom, boom, boom. Right. And so we have, here we have this x minus 4 squared. What's our derivative of that? What's our derivative of this?
2x minus 4.
Yeah, that's it, right? So there we have that. And then we have this next one. We have 4x minus 4. What's our derivative of this? 4, right? So now we have f double prime of x. It's equal to 4 times, we have x minus 4 squared. And then we have the next one here is going to be plus 2 times x minus 4 times 4x minus 4. And what's going to be our common factor in these things here? What's going to be our common factor between these two things here? Yeah, x minus 4, and I also would suggest not only that, it would be like 2 times that, because we got a 2 here and here. So 2, we have x minus 4. That's our common factor between these two. And so next, I'm kind of here. I noticed something here. I just noticed something. Anybody else notice it? I just noticed something that's going to make your life easier. Okay, here, what we have for here, this one we can rewrite as 4 times x minus 4, right? So this one here is really going to be 4 x minus 4 squared plus, what we have is, this is 4 x minus 4.
How come you can put 4 in there, because there's a 2?
Oh, you're right. I can't do that.
But you can keep the 2 in it.
Yeah, let's do that.
Easy, but
Yeah, so I thought I was being smart, but I wasn't.
But you can keep that, but I guess.
Yeah. So anyway, that's going to be 4x So really what we have is this. So we can just do this. So we're going to have times
And
2.
Get rid of the 4 in the front, and this be 2. Of the following equation.
No, because 4 times that. Right?
I'm confused. Yeah.
4 times
I thought you
that.
were taking out what can be,
Plus this times this. So here's, over here is this times this, and over here is this times this. And so now what we have is this, and our common factor between these two is this x minus 4. And so we factored out of x, this out of this, we have just, we factored out what 2 is going to be factored out of that. That's right. Yeah, thanks. So 2x, so here we're going to have 2 left over, 2 times x minus 4. And then we're going to have plus, we factored out this, so we're going to have 4x minus 4. And so what we have to simplify, we have 2x minus 4. And then over here, we're going to have 2x plus 4x is 2x plus 4x is 6x. We have 6x. And then here we're going to have 2 times negative 4, that's negative 8. And negative 8 minus another 4 is negative 12. And so that's going to be it. And if we set that equal to 0, we get our critical numbers are going to be x equals 4 and x equals, let's see, is it 3? 2. It's 2, right? X equals 2. That's right, isn't it? So now we can go ahead and put our critical numbers here. For this one, we have 2, 4, and we have f double prime f. And then if we go for less than 2, we have a what times a what? Negative times negative. So we're going to go like this. And then when we pick a number between 2 and 4, we have a negative, or it's just going to be a positive times a negative, right? And then for greater than 4, we have positive times positive. So we're looking like that. So we have a point of inflection where x equals what? X equals 4, because f double prime does what? Changes. Now, it changes from plus to minus or minus to plus. So if you abbreviate that, so it changes signs, right? Changes signs from positive to negative and from negative to positive. So we can put it that way. So is that pretty much everything on that one? So to me, what's the hard thing on this one? Because you can see there's a lot of tedium. What do you say? Yeah, kind of a lot of work, kind of a little tedious. The factoring is more complicated. Takes some time to sort of work through, figure out what's going on. You have your product rule use of that, so it kind of combines quite a few things that we've been doing in the course so far this year. And I think I had it worked out from last year. Yeah, it's the same thing, right? Yeah. That was from last year. Yeah, x equals 2, x equals 4. Okay. Go on here. Now this one here, I want you to do this one. Same process. Find your critical numbers. Take the derivative. Find the critical numbers. We'll go over this in a few minutes. Okay. Find your critical number, first derivative, critical number. Go through that process.
We only take the denominator, right?
Right, what I would do is I'd use the quotient rule on this one. Remember what the quotient rule is? Quotient rule.
Low d high minus high d low.
Try to see if I can remember it. One thing I thought about this morning is it's getting closer to Christmas, right? And so we're going to have to be doing some Christmas songs, do you think?
Yeah, sure.
Lodi, 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 high.
What?
Minus high, high, low. All over lows. Lodi, 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 high. Minus high, high, low. All over lows. Remember that song? You should remember that song.
I do.
That's the one that's hard for the girls to sing. But I hope as you do these things, you're developing your calculus toolkit that you can go and reach back into to do certain things. But what's the important thing about having a toolkit? The tools need to be there, right? How do you keep the tools in the toolkit? By the practice, by reviewing these things. And one thing that I really am happy about this class this year is you guys really helped this class and future classes with a big part of what a good toolkit is. And what is that? The calculus song. Because you lit a fire under my rear end to tell me to do it. And you see that little guitar up there that Elizabeth drew? You see that guitar? That may not seem like much, but that's an important part of what I saw, because when I opened that up and read that note, Elizabeth, what did you say? Do you remember what you said?
No, I don't.
What it is, she said she liked the songs and they helped her learn, right? And so that's something you did. Did you do that as part of your art class?
We were making cards for teachers.
So she made a card for teachers. So she has this card that is just, it's her art class project, and she put it in, and that's a really good piece of art in and of itself. Okay, no doubt about it. But the thing that was really that I thought about was the note. She had the note, and she specifically mentioned about the songs and so forth. And so this is part of what I was thinking about when I was saying, yeah, I need to write that song. I need to write the song, all right? And also it encouraged me to kind of think of singing those songs more, because I don't know. That's just how I'm thinking right now. But this is a good example of that you do something to help somebody out that it might be a little bit thing. It might be something that to you might seem like a little thing, but it could be a big thing to somebody else, whoever you help out, like this did. So this is what I got for the first derivative, is that right? It's right. Kaylee thinks it's right. Anybody else think of, so did you get the same thing for that? And I promise you, when I wrote this thing, you know what I was thinking of when I wrote this thing? The song. I was thinking of the song. Karina, did you see what is happening here? Okay. So now we have this. What are we going to do next for this one to find our critical numbers? Critical numbers are what? Where f prime of x is equal to 0 or undefined. Thank you. And so now, so what we have in this instance, we have 0 is equal to 12 x cubed minus 6 x squared. And so we're going to find one critical number. What else do we have to set equal 0? This thing down here, right? So we have 0 is equal to 3x minus 1 squared. And so now, the greatest common factor I'm seeing here, I'm seeing 6x squared. And then here, left, we're going to have 2x minus, what's this going to be here? 2x minus minus 1. And then over here, we're going to have 0 is equal to 3x minus 1. And so x is equal to 1/3. And over here, for this one, we have x is equal to x is equal to what here? For this to be 0, what does x have to be equal to? So basically, if this factor is equal to 0, so x is going to be equal to 0, and x is going to have to be equal to 1/2. Okay? So these are all of our critical numbers right here. And then we can make a number line to find out what happens here. So we have 0, 1/3, and 1/2. So here we have f prime, f double prime, and this is one that has a little bit more complexity to it because one's in the numerator and one's in the denominator. So what you can do is you can stack these one upon another. You can say, okay, we'll call this one this thing right here, which is just going to be 0 and 1/2. And then this thing over here is going to be this denominator. And so we have 1/3 over here. And so we know that's equal to 0 here. That's equal to 0 here, equal to 0 here. But here we're dividing by 0. So for this thing here, we're going to have a number less than 0. If we take a number less than 0, what are we going to have? Well, this is always going to be positive here, right? And this is going to be negative. So we're going to have negative here, and less than 1/2, we're going to be negative here and negative here. But what about greater than 1/2? That's positive. What about this 1/3? Well, less than 1/3. Well, these are always going to be positive, right? It's everywhere else positive. So now, if we go ahead and put those two together, f prime of x and f, and we put those critical numbers together, 0, 1/3, and 1/2, we can look, what's a negative divided by a positive? Negative, right? So we know we're decreasing there. And then at 0, we have 0, actually we're dividing by 0 here, right? So what's this going to be here? No, this one's going to be undefined, because we're dividing by, no, actually 0's over there. I'm lying to you. I don't mean to lie to you. Okay, and then here we have here, greater than 0, we have a negative divided by a positive, which is negative. Okay, and now this is where we're taking negative divided by 0. What's that going to be? Undefined. And then here we have negative divided by positive, which is negative. And then finally, at greater than 1/2, we have a positive. So where do we have a relative? Do we have a relative maximum? No, right? We have a relative minimum at x equals 1/2. And then we can plug back in x equals 1/2 where? Right here. So we have 2 times 1/2 cubed over 3 times 1/2 minus 1. So what that's going to do here, that's going to be, what's 1/2 cubed? It's going to be 1/8, right? So, yeah, so 2 over 8 is going to be like 1/4 up here. And then we have, what's 3 over 2 minus 1? That's going to be 1/2, isn't it? So we have 1/4 divided by 1/2, which is going to be, that's going to be 1/2, isn't it? Because it's like multiplying this by 2. 1/2. 2. So we have the point of, so the relative minimum of 1/2 where x equals 1/2. And now to get our other one, to get our point of inflection, we have to take the derivative of this, don't we? But that's going to be some work, isn't it? I know we'd have this, we'd end up with still the same critical numbers down here, but this one here, it's going to multiply our complexity quite a bit to do that. So, but it can be done, right? We can do Lodi high again a second time, and then we would get okay, didn't do that last year. But anyway, that's the process right there. So it's just a lot of, to me, going and doing this doesn't, I mean, but to go to that next thing and do that, that's going to ratchet up your complexity quite a bit. But it's a process of going through this. And these types of things where you have a numerator and a denominator and stack them up like this, that's one thing you can do. You can check in a calculator, see what it looks like. Yeah, I'm going to just save it here. I don't even want to do that one. Okay, we're going to do what I plan to do on Monday is come and look at these functional relationships here. So we're just going to come back here on Monday to page 439, and we'll just leave it there today. All right?